Welcome. I'm Ramya Devi, working as Assistant Professor in Computer Science and Engineering Department at Hindustan College of Engineering and Technology. In this video, we're going to see OSI model, Open System Interconnect. So this is an architecture which defines a partitioning of network functionality into 7 layers where one or more protocols implement the functionality assigned to a given layer. So this is an example where we have 7 layers starting from the basic bottom layer is a physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. So we'll see each and every layers in detail. So we're starting from the physical layer. So actually the data will, if host wants to send the data will be sending from the top layer, the application layer, not the physical layer. The data will, it's actually the top down approach. From the application layer, the data will be given to the next layer, that is presentation layer. So application layer, it will be serving as a window for users and application process to access the network service. So it handles issues such as network transparency, resource allocation, everything will be handled by the application layer. So in this layer, the data will be represented as a data itself. So the file transfer, access and management, mail services, directory services, everything will be taken care by the application layer. The next layer is the presentation layer. Presentation layer, it does translations. So the process into systems exchanges the information in the form of character strings, numbers, and so on. So different computers will be using different encoding methods. So the presentation layer handles the interoperability between the different encoding methods. And also the encryption, compression will be taken care by the presentation layer. So the presentation layer, it also handles the data in terms of data itself. So the next layer is a session layer. Dialog control, synchronization, everything will be taken care by the third layer, that is the session layer. So dialog control, the session layer, which will be acting as a dialog controller, which will be creating a dialogue between two processors, or we can say that it allows the communication between two processes, which can be either half duplex or full duplex. So synchronization in the sense, say for example, if this host is capable of sending 512 bytes of data and this host is capable of receiving 256 bytes of data. So what will happen at a stretch, if I'm sending 512 bytes of data, the rest of the only 256 will be accepted. The buffer size, since the buffer size is 256, and the rest of the bytes will be dropped. So there should be some synchronization mechanisms before sending the data from one host to another host. This will be taken care by the session layer. The next layer is the transport layer. The transport layer, the responsibilities of transport layer are segmentation, reassembly, and the session will be created before sending the data. Okay, logical connection will be established between the host sender and the receiver before sending any data. So for this, there are two types of applications. If it is a wired network, it uses TCP protocol, which needs connection establishment, logical connection, three-way handshaking mechanism between the host and sender and a receiver. If it is a wireless network, it uses UDP, where this is not, connection establishment is not required. Okay, so it does segmentation and reassembly, connection control, flow control, and also error control. Segmentation in the sense, if the data is coming from the session layer, if it is too long, the data will be divided into segments, and each and every segment will be having a sequence number. So what is the purpose of sequence number? In the sense, once the data, it is a packet switch network, so the packets will be arriving at the destination in an unordered way. So once it reaches the destination, reassemble can be done if all the packets are having a sequence number. For that only, the transport layer, each and every segment, the data and the transport layer will be represented as a segment. So each and every segment will have a sequence number. It also does connection control, flow control, and error control. And the next one is network layer. The functionalities of network layer are internet working, addressing, routing, and packetizing. So in this layer, the data will be represented in terms of packets. So the source IP address and destination IP address. So say for example, if it is a local area network, so local area network will be identifying a system in terms of MAC address. MAC address is more than enough to communicate with two different systems. So if there are two LANs connected with the help of an internet, okay, geographically separated, two LANs are connected with the internet. So I cannot have a MAC address in order to identify. The MAC address is not it is not more than enough to identify a system when it is connected with the internet. In that case, we'll be using IP address. So the packets will have IP address of source and IP address of destination, where the segments will have MAC address of source and MAC address of destination mission. So the addressing, networking, which way the packet should travel, and the routing information, packetizing, everything will be taken care by the network. So in the network layer, the data will be represented in terms of packets. The next one is data link layer. The data link layer, it also does framing. So the data will be represented in terms of frames, framing, physical addressing, flow control, error control, access control, everything will be taken care by the data link layer. So flow control, error control, it is actually the replicated techniques which also taken care by the transport layer. In this case, it is node to node, host to host services, actually from one host to another host. In this case, data link layer, it does flow control and error control node to node. Node to node in the sense, if these two systems are connected with the help of two different routers, say for example R1 and R2, the flow control and error control will be taken care by each and every node to node. This will be done by the data link layer, but the transport layer does flow control and error control between host to host. That's a difference. So the next one is physical layer. Physical layer, the data will be actually represented in terms of bits. The physical path, it can be wired connection or line configuration. The data transmission, the topology, signals, that will be handled by the physical layer. It is actually the connected or a wireless, or whether it is simplex, half duplex, full duplex mode, everything will be checked by the physical layer. So these are the responsibilities of different layers, and each and every layer will have its own functionalities. That's what we've seen. So that's what I've said. So the top three layers will represent the data in terms of data itself. The transport layer, it represents data in terms of segments. Network layer in terms of packets. Data link layer, frames, and physical layer, bits. So application layer, it is network process to process applications, and the representation, the encryption, data representation, everything will be taken care by the presentation layer. Session layer, it does inter-host communication. Transport layer, end-to-end connection, logical connection is required, and it offers reliability once the logical connection established between host to host. So the network layer, the path determination, logical addressing, everything will be taken care by the network layer. And the data link layer, MAC and LLC, media access control and logical link control will be taken care by the data link layer, the physical addressing. Physical layer, it does how the data is actually transmitted, in what way the network is being connected, and how the data is transmitted from one host to another host will be taken care by the physical layer. So the protocols in the application layer are HTTP, FTP for file transfer, the simple network management protocol, simple mail transfer protocol, telnet, SSH. So these are the example protocols used in application layer. Transport layer, we have TCP, UDP as well as SCTP. the third protocol, which will not be discussed in most of the books or even the network sources. But the transport layer, it offers three protocols: TCP, transmission control protocol, user datagram protocol, and screen control transmission protocol. So we have SETP also. So the network layer, IP, ICMP, ARP, address resolution protocol, dynamic host configuration protocol. All these things works in network layer. Data link layer, we have PPP, EAP, XDA, SL, Ethernet, in order to handle the data in terms of frames. We have discussed OSI 7-layer model. Thank you.